Hey y'all, we are looking at adding and subtracting polynomials now. Now you may not know what polynomials are, but you definitely know what adding and subtracting means. And polynomials will kind of get into what it actually is, but it is not something that you are unfamiliar with. So today's goal is to be able to add and subtract polynomial expressions. And we're going to have to use the distribution property, potentially, where we multiply when we see parentheses. We're going to have to identify like terms, add or subtract like terms, so combine like terms, and then rewrite the polynomial expression in standard form. We've talked about standard form with linear functions. We've kind of stepped away from it, and we're going to talk about a general understanding of what standard form is, kind of across any type of function. So let's get started. First of all, a polynomial is an expression that has more than two algebraic terms separated by addition or subtraction signs, so by plus and minus signs. Instead of writing addition and subtraction, I just wrote plus and minus. You can write what you want. So what the heck is a term? I'm going to skip down here and fill in what a term is. So a term is a single number or variable, or numbers and variables put together. So an example of a term: 3 could be a term, -4, 4x, -2x, y, x squared. Those are all example of terms that, when put together and separated by an addition sign or subtraction signs, form a polynomial. We're going to talk about the degree of a polynomial. Like, hey, what's the degree of that polynomial? And the degree of the polynomial is always dictated by the highest exponent. And that'll make more sense when we start looking at examples and talk about it. But for now, just knowing it's dictated by the highest exponent. And standard form, it's written from highest degree to the lowest degree. So an example would be something that says like 4x squared minus 3x plus 2, where we can see here the degree is 2 because the exponent's 2. This is a degree of 1, and this doesn't have an exponent after the variable, so it would be the lowest degree. Okay, so that's standard form. Another important definition, vocabulary term, is leading coefficient. So when we're writing in standard form, it's the first term, or the first coefficient. So it's the number in front of a polynomial, in the front of the term. So in my example up here, 4x squared minus 3x plus 2, 4 is my leading coefficient because it is the first coefficient when written in standard form. And our last vocabulary word, what's a constant? We've talked about that before. It is a number that stands alone, like those examples I have up above, 3 and -4. Those are both constant. It's a number that is alone or stands alone. So let's look at this example down here at the bottom, just really quickly going through these vocab. Each of 7x to the 5th power, 2x squared, and -3 are all terms. That -3 is a constant because it has no letter with it. Our degree is dictated by that highest exponent, that is 5, so our degree would be 5 for this polynomial. And our leading coefficient is attached to the highest exponent. It is the number in front, so that 7 is our leading coefficient. And I just abbreviated it there. So now that we kind of know what standard form looks like, written in order from highest degree to lowest degree, and we've talked about some vocab terms, let's go ahead and see if we can add and subtract those polynomials, combining like terms and simplifying our polynomials. So here in example 1, we have 2 polynomials. We have a set in parentheses and then plus another set of parentheses where they have 3 terms each. right? Each term is, again, its own little individual part of number, letters, separated with those either pluses or minuses. So what we need to do to combine like terms is identify what are the like terms. Now, you already know that the x's go together and the constants go together, but what you may not know is that x squareds are different than x's. So x squareds don't equal x's, which means it's their own variable. And just like we started the year with combining like terms by kind of identifying them, either by circling the like terms or underlining them, we're going to do that here, so that we can combine those like terms through addition. So I'm going to start with my farthest left, and I see 3x squared. So I'm going to look and see, do I have any other x squareds? I do, a 4x squared right there. So I can rewrite those now as 3x squared plus 4x squared. Now I need to look at my x's. I have 5x and I have 2x. Plus 5x plus 2x. And then I have to end, I have a 7, I'm going to triangle that. I have a 7 and a negative 3, so plus 7 minus 3. And now all I have to do is combine those terms. So 3x squared and 4x squared, how many x squareds do I have? 7x squared. 5x plus 2x, how many x's do I have? 7x. And 7 minus 3, I have 4 left. My last step is to check that your polynomial is written in standard form from highest to lowest degree. This one is, so we are good to go. So that's pretty easy with adding. We just add them all up. Where it's a little bit trickier is when you are subtracting polynomials, because you have a negative outside of one of my set of parentheses. You might recall from the beginning of the year, when we have a negative outside the parentheses, it's as if we have a negative 1 outside the parentheses. And so we need to first, before we can combine like terms, distribute that negative 1 to all the terms inside the parentheses. So I'm going to do that first, and then I'm going to come back, and then I can combine my like terms. So nothing happens with the first set of parentheses because there's no negative outside of that. But that negative then is going to change all of my signs here. And because I'm applying that negative 1, but multiplying it, I don't need to have parentheses anymore. But I could keep them if I wanted to. So now I've changed each of the signs because I multiplied by negative 1, and now I can get to combining my like terms. Same thing, I'm looking for the squared m squareds first. I remember to circle the sign in front, going to be super, super important. And then I'm looking at my m's next. I'm just going to underline them. Plus m plus 4m. And then looking at my constants, 10 and negative 6, plus 10 minus 6. And then once again, I'm just going to combine those like terms to write my answer in its final form. Remember, I can't combine any squareds with non-squareds. Same thing if I was to a power of 3, I couldn't combine that with a power of 2 or a power of 1. So 2m squared minus 5m squared is negative 3m squared. m plus 4m is 5m, so plus 5m. 10 minus 6 is 4, so plus 4. What's my leading coefficient? Negative 3. Leading coefficient. 2 is my degree, and this is written in standard form here. Again, remember, we should be checking that it's written in standard form. But here's where it's going to get a little bit maybe weird or weirder just to look at is when we have multivariable polynomials. Look at example number 3. I have a's and b's together, b's and c's together, and a's and c's together. Those are just individual variables. If an a and b is next to each other, we treat that as that's the variable ab. So we can only combine it with other ab variables. and so on and so forth. Now, what does standard form look like? We should probably write that in alphabetical order, but when you see on those star questions on the next page that we're going to look at, you can kind of use context clues to help you figure out the order. But once again, we're just going to identify like terms, so 7ab with the negative 3ab, the bc and negative 8bc with a, ooh, look though, what did I miss? The negative. Let's make sure we always check for that and distribute that and then rewrite it, because that is going to completely change this problem. Okay, so now I've rewritten it, and now I can combine those like terms. So looking at the AB and the positive AB, the negative 8BC with the negative 4BC, and the negative 10AC with the negative AC. Rewrite to combine, putting the ABs together, the BCs together, and the ACs together, and then I can write my final answer. Combining like terms, then I have 10AB minus 12BC minus 11AC. Now, the only thing I need to do to put this in standard form is kind of keep it more alphabetical. So 10AB would go first, but the minus 11AC, and then going to the negative 12BC. Again, you're going to probably have answer choices that will put it in the correct order for you, but that is my final answer. So things to remember: check for distributing the negative when you are subtracting polynomials, and then combining like terms. Give these two star questions a try, and then come show them to me when you're done, and let me know if you have any questions.